The Hercules Corona Borealis Great Wall is the largest known structure in the universe, a chain of galaxies stretching more than 10 billion light-years across. It's so massive that its existence breaks some of our biggest cosmology rules. Structures this large aren't supposed to form in the age of the universe we see. Yet there it is, a cosmic wall made of countless galaxy clusters, stretching farther than light has traveled since the Big Bang. It's one of the universe's greatest mysteries. Fast radio bursts are one of space's biggest mysteries. Powerful cosmic signals that last just a few milliseconds. They appear out of nowhere, brighter than entire galaxies for a split second, then vanish. Some repeat, some fire only once, and we still don't know exactly what creates them. Colliding stars, magnetars, something stranger. All we know is that these signals travel billions of light years, and they keep coming. The solar gravitational lens isn't just a wild idea. It's a real mission concept actively studied by NASA's Jet Propulsion Laboratory. The goal is to send a spacecraft more than 550 astronomical units from the Sun, far beyond the Kuiper Belt, to a point where the Sun's gravity can magnify the light of a distant exoplanet. If a mission like this launches in the coming decades, we could capture images of another Earth with enough detail to see continents, oceans, and even atmospheric structures. Empty space looks calm, but on the quantum level, it's chaos. The vacuum constantly creates tiny particle-antiparticle pairs that pop into existence and then vanish almost instantly. These fluctuations are so real, they affect gravity, push on metal plates, and even help shape the expansion of the universe. What we call nothing is actually one of the most active places in physics. Corot 7b is one of the most extreme rocky planets ever found. It orbits so close to its star that a year lasts just 20 hours, and its entire day side is a molten ocean of lava. Temperatures soar high enough to vaporize rock, creating mineral clouds that may rain molten droplets back down onto the surface. It's a world where stone behaves like water, and nothing solid can survive. Every time you look at a map of the night sky, there's a ghostly glow hiding behind everything. The cosmic microwave background. It's the oldest light we can see, released about 380,000 years after the Big Bang, when the hot plasma of the early universe finally cooled enough for atoms to form and space turned transparent. That baby universe glowed at about 3,000 degrees, but as space expanded, the light was stretched into cold microwaves just 2.7 degrees above absolute zero. Today, that faint afterglow fills the entire sky, a frozen snapshot of the moment the universe went from fire to light. The pillars of creation are one of the most iconic structures in the universe, towering clouds of gas and dust where new stars are actively forming. Inside these dense columns, gravity pulls material together until it ignites into newborn suns. The pillars look calm from afar, but they're actually shaped by intense radiation, shock waves, and stellar winds from massive nearby stars. It's a cosmic nursery, sculpted by both creation and destruction. If the sun were replaced by a black hole of the same mass, Earth wouldn't get sucked in. Our orbit would stay exactly the same, because gravity depends on mass, not light. But everything else changes instantly. The solar system goes dark, temperatures drop toward absolute zero, the planets freeze, and the only sign of the sun's former power would be an invisible sphere warping starlight as it bends space around it. The atoms in your body didn't start on Earth. They were forged in stars. Hydrogen fused into helium, helium into carbon and oxygen, and the heaviest elements formed in supernovas so powerful they can outshine galaxies. Every carbon atom in your cells, every oxygen molecule you breathe, every bit of iron in your blood was created in a dying star. You are literally made from the ashes of long-dead suns. Iapetus is one of the strangest moons in the solar system. Half of it is bright like fresh snow, and the other half is as dark as charcoal, creating a natural yin-yang design across its surface. Even weirder, it has a massive equatorial ridge that wraps around the entire moon like a cosmic mountain belt. Scientists think the dark material may come from another Saturnian moon, while the ridge hints at a past that was far more active than anyone expected. The Milky Way is surrounded by a massive halo of dark matter, an invisible sphere that's far bigger than the galaxy itself. We can't see it, but we know it's there because stars orbit too fast to be held in place by visible matter alone. This hidden structure shapes how the galaxy forms, how it moves, and how everything inside it stays together. Without the dark matter halo, the Milky Way would fly apart. Cryobots are one of the most promising tools for exploring alien oceans. Instead of drilling, these cylindrical robots melt their way downward through thick ice using heat from onboard power sources. The idea is to send them to worlds like Europa or Enceladus, where oceans hide beneath miles of frozen crust. Once a cryobot reaches the water below, it can release a small submarine to search for life in places sunlight never reaches. What we see when we look into space isn't the whole universe. It's just the part light has had time to reach us. The observable universe is a sphere about 93 billion light-years wide. But the actual universe? It could be hundreds of times larger, maybe infinite. Beyond our cosmic horizon are regions we will never see because their light will never reach us. We're living inside a tiny bubble of something far bigger. K2-141b is one of the most extreme planets ever discovered. It's so close to its star that one entire side is a molten lava ocean, while the other is locked in eternal darkness. Rock heats up, vaporizes, and forms a thin rock atmosphere that gets blasted around the planet at thousands of kilometers per hour, creating supersonic rock winds. On the night side, that vapor cools and rains back down as solid stone. At the outer edge of the Kuiper Belt, something strange happens. After trillions of chunks of ice and rock orbit peacefully around the sun, the population suddenly drops off, almost to zero. This sharp boundary is called the Kuiper Cliff. Scientists don't know why it exists. Maybe a passing star cleared the region, or an unseen planet disturbed it long ago. Whatever caused it, the Kuiper Cliff marks one of the solar system's biggest mysteries. What if one side of Earth always faced the sun? Half the planet would be locked in endless daylight, an overheated desert with scorching skies. The other half would sink into permanent night, frozen solid beneath stars that never move. Between them would be a thin twilight ring where temperatures are survivable. A tidally locked Earth would become a world split in two. Blazing light on one side, eternal darkness on the other. Magnetic fields are everywhere in the universe, shaping planets, stars, and even entire galaxies. They guide charged particles, twist gas into spirals, and carve patterns into nebulae. Around black holes, magnetic fields help launch jets that fire across thousands of light years. Invisible but powerful, magnetism is one of the quiet forces sculpting the cosmos. Dysnomia is one of the most remote and mysterious moons in the solar system. It orbits Eris, a distant dwarf planet even larger than Pluto, in the frozen darkness of the Kuiper Belt. Dysnomia reflects almost no light, making it incredibly hard to study, and its exact composition is still unknown. But its tight, stable orbit helps scientists measure Eris's mass with precision, revealing just how strange and dense this distant world really is. Cryogenic sleep pods are one of the most promising ideas for long-distance space travel. Instead of staying awake for years, astronauts would enter a controlled, low-temperature hibernation state that slows the body's metabolism almost to a stop. This reduces food, oxygen, and water needs to a fraction. The technology is still experimental, but if perfected, cryogenic sleep could make multi-year missions to the outer planets, or even nearby stars, actually possible. Space itself is expanding, not like an explosion, but like the stretching of a fabric. Galaxies aren't flying away on their own. They're being carried apart as the space between them grows. And the farther a galaxy is, the faster it appears to move away. This accelerating expansion is powered by something mysterious called dark energy. Over billions of years, it will push galaxies so far apart that distant ones will fade from view entirely. When massive stars die, they don't just explode, they launch supersonic shock fronts that race through interstellar space. These waves compress gas, heat dust, and carve entire shapes through nebulae, sometimes traveling hundreds of kilometers per second. As they sweep through the galaxy, shock fronts can trigger new stars to form, or completely blow clouds apart. And right now, the Milky Way is full of them. Invisible until they slam into dense gas and light up in X-rays and glowing filaments. A reminder that even the quiet spaces between stars are shaped by violent cosmic winds. In a brand new discovery, scientists analyzing samples from asteroid Bennu just found tryptophan, a complex amino acid, and one of the 20 used by life on Earth. It's the first time tryptophan has ever been detected in a meteorite or asteroid sample. Bennu already contained water-altered minerals, phosphate, nucleobases, and 14 amino acids. But this new finding pushes things further. It suggests that the building blocks of life can form deep in space long before planets exist. This doesn't mean Bennu had life, but it means asteroids like it may have delivered the ingredients that eventually helped life emerge on Earth. A reminder that the story of life might begin far beyond our planet. Humanity's energy needs are massive, but what if we could tap the full power of our sun? Engineers and researchers are actively studying space-based solar power, including orbital mirror systems designed to boost solar output on Earth. Early concepts propose arrays of reflective satellites directing concentrated sunlight onto ground solar farms, providing clean, continuous power. And on a larger scale, scientists have modeled Dyson swarm architectures, thousands of small collectors orbiting the sun to harvest star-level energy. It's not science fiction anymore. These ideas are being seriously researched today, a reminder that tomorrow's energy might come from far above us. Quantum entanglement is one of the strangest things we've ever discovered. Two particles can become linked so deeply that measuring one instantly affects the other, even if they're on opposite sides of the universe. This isn't communication or magic. It's a sign that entangled particles behave like a single system, not two separate objects. Experiments show the connection is real, unbreakable, and faster than any signal allowed by physics. Reality is far more connected and far stranger than it looks. Most gas giants look blue, brown, or gold. But GJ504b breaks the rules completely. This massive planet glows with a deep magenta hue, created by heat trapped in its atmosphere and the way it scatters infrared light. It's far younger and hotter than Jupiter, and its atmosphere may contain exotic clouds unlike anything in our solar system. Observations suggest it shines with its own thermal light, making it one of the most colorful worlds ever discovered. In a universe full of familiar patterns, every so often a planet shows up that looks like pure imagination. The Milky Way looks flat in most illustrations, but the real galaxy is bent and twisted, almost like a cosmic wave frozen in space. Astronomers discovered this by mapping thousands of stars far from the galactic center, revealing that the disk doesn't sit in one clean plane. It curls upward on one side and downward on the other. The warp may come from dark matter past collisions, or the pull of distant satellite galaxies. Whatever the cause, it shows our home galaxy is still flexing and shifting across billions of years. The Milky Way and Andromeda will collide in about 4 billion years, but imagine if the crash happened now. Our night sky would erupt with a growing swirl of stars as Andromeda stretched across the horizon. Gravity would tear apart stellar orbits, fling star systems into deep space, and distort both galaxies into long, glowing streams. Earth wouldn't be destroyed, but our place in the galaxy would be reshaped forever. Makes you wonder, what would our sky look like the moment two galaxies truly begin to collide? Space is filled with high-energy particles that never reach Earth's surface, but in orbit, they pass straight through the human body. These particles can snap DNA strands, change genetic instructions, and force cells to scramble their repair systems. Astronauts develop unique mutation patterns, shifts in immune behavior, and measurable changes in gene expression. Most effects fade after returning home, but some leave a lasting mark. It shows that human biology was never designed for raw cosmic radiation. Proteus is one of the darkest objects in the entire solar system. It reflects almost no sunlight, making it look like a massive charcoal block drifting through Neptune's orbit. Despite its size, it's so dim that we didn't even see it clearly until Voyager 2 flew past in 1989. Its surface is scarred, jagged, and frozen, shaped by billions of years of impacts. Proteus may look simple, but it represents a world sculpted in deep shadow far from the sun. In a universe full of chaotic clouds and swirling gas, the Red Square Nebula stands out for one impossible reason: its geometry. This object forms nearly perfect right angles, creating a glowing pattern that looks engineered rather than natural. Astronomers think the shape comes from a dying star shedding material through two opposite cones, creating the sharp, square-like symmetry. Even so, nothing else in space has lines this clean. It's a rare reminder that the cosmos still produces shapes that feel almost impossible. In deep space, weightlessness slowly weakens muscles, bones, and even the way the heart pumps. That's why engineers are exploring artificial gravity rings, giant rotating habitats that create spin gravity through centrifugal force. As the structure turns, everything inside is gently pushed outward, mimicking the pull of gravity on Earth. It could let astronauts walk, sleep, and train normally on long missions. If humanity ever builds true space cities, this is almost certainly how they'll feel like home. At the smallest scales imaginable, space-time isn't smooth or still. It churns, it flickers, it twists into tiny, momentary distortions called quantum foam. Particles appear and vanish in trillionths of a second, and space itself curves and uncurves so fast that it becomes impossible to pin down. This chaotic activity happens everywhere, even in the space right in front of you. If we could truly see quantum foam, reality would look far stranger than the calm universe we think we live in. Kepler 70b is one of the most extreme planets ever discovered. It orbits a dead, superheated subdwarf star in just 5 minutes, the shortest planetary year we've ever found. The planet is scorched to nearly 7,000 degrees Celsius, its surface hotter than many stars, and likely made of dense, stripped-down stellar material. Kepler 70b survived its star's violent expansion, leaving behind a tiny molten world racing in a tight orbit. It makes you wonder how many planets can endure their star's death and still remain. On the sun, plasma doesn't just rise, it also falls. When superheated gas in the corona cools, it condenses into bright arcs that plunge back toward the surface at hundreds of thousands of kilometers per hour. These glowing streams are called coronal rain, and each one can be larger than Earth. They trace the sun's magnetic loops, revealing invisible structures that shape solar storms and flares. It makes you wonder what other kinds of solar weather we've barely begun to understand. If space were filled with air instead of vacuum, the universe would behave nothing like it does now. Orbits would collapse instantly. Planets and satellites would slam into their stars as drag slowed them down. Sound would travel across the cosmos, but starlight would scatter into a hazy glow. Even galaxies couldn't form the same way because gas pressure would resist gravity at enormous scales. A universe with air isn't just different. It's one where almost nothing we know could survive. Across the galaxy, tiny grains of cosmic dust drift between stars, and some of them carry complex organic molecules. Laboratory experiments show that amino acids, sugars, and other building blocks of life can form inside icy dust grains and survive harsh radiation. If those grains are launched by supernova shockwaves or blown off newborn stars, they can travel incredible distances. It means the raw ingredients for life might not be limited to one world. They could be quietly spreading through the galaxy. Far beyond Neptune, the dwarf planet Orcus has a companion unlike almost any other moon. Vanth is large enough and close enough that the two bodies actually orbit each other, forming a near-binary system. Its surface appears darker and more complex than Orcus itself, hinting at different materials or a very different origin. Some models even suggest Vanth may have formed from a colossal impact billions of years ago. Out in the Kuiper Belt, even small worlds can have stories shaped by violent beginnings. The Blue Ring Nebula is one of the rarest objects ever discovered, a glowing structure formed when two stars merged into one. As the new star stabilized, it launched twin cones of gas that expanded into space. From Earth, we see those cones overlapping, creating a striking blue ring. No other nebula looks like this, and we've caught it at a stage that lasts only a moment in cosmic time. It's a glimpse of a stellar transformation we almost never get to witness. In the 1960s, engineers designed one of the boldest starship concepts ever proposed, a craft propelled by nuclear pulse explosions. The idea was shockingly simple. Detonate small nuclear charges behind a massive pusher plate and let each blast drive the ship forward. Calculations showed an Orion-style starship could reach a fraction of light speed, fast enough to cross interstellar space within a human lifetime. It's a reminder that sometimes the most ambitious ideas nearly became real. Right now, you exist in a strangely perfect moment in cosmic history. The universe is old enough for galaxies to form and young enough that we can still see them. Stars shine across the sky, and the cosmos remains readable to anyone curious enough to look. In the far future, expansion will push galaxies beyond the cosmic horizon, and the night sky will fade into darkness. Evidence of the Big Bang will disappear, and the universe will become harder to understand. But we live in a rare moment when the cosmos is bright enough to study and mysterious enough to inspire wonder. Imagine standing on a world where the sky never looks the same twice. The GW Ori system contains 3 stars twisting around each other in a massive gravitational dance. A planet here would orbit inside a warped ring of dust tilted in several directions at once. Sunsets could come from 3 angles, shadows would split and merge, and the sky would shift dramatically as the stars move. Astronomers believe this system may already host a giant planet forming inside its broken rings. Moments like these show how wildly imaginative the universe can be, long before we ever dream it. Every second, an invisible storm of particles is passing straight through you. These particles are called neutrinos, and they come from nuclear reactions inside stars, from exploding supernovas, and even from the beginning of the universe itself. Trillions of neutrinos stream through your body every moment without leaving a trace, because they hardly interact with matter at all. Detecting them requires massive underground tanks waiting for a single rare collision. Moments like these reveal how much of the universe moves through us without ever being noticed. If the sun somehow doubled in mass, the entire solar system would feel the change instantly. Stronger gravity would pull Earth into a tighter, faster orbit, bringing us closer to the sun and raising global temperatures. Seasons would shift and days would shorten as our planet moves more quickly along its new path. The increased solar energy would reshape weather patterns, and the outer planets would drift into destabilized orbits. A sudden change in the sun's mass would turn our familiar solar system into a place ruled by rapid and unpredictable motion. Light is the key to understanding worlds we may never reach. When a distant planet passes in front of its star, some of the starlight filters through the planet's atmosphere. That thin slice of light carries chemical fingerprints revealing molecules like water vapor, methane, carbon dioxide, or exotic gases that could not exist on Earth. Astronomers use these patterns to study temperatures, winds, and atmospheric layers from light years away. Alien atmospheres become readable long before the planets themselves come into view. Long before planets formed, small icy bodies drifted through the newborn solar system. Arrokoth is one of them. It is a contact binary made of two ancient lobes that gently merged billions of years ago, and its surface has remained almost unchanged ever since. With no atmosphere, no weather, and almost no collisions, Arrokoth preserves the original building materials of our cosmic neighborhood. Studying it offers a direct look at how the earliest worlds first began to grow. Astronomers once found a ghostly galaxy that broke one of the biggest rules in modern astrophysics. When they measured its motion, the stars were moving slowly instead of racing around as they should if dark matter were present. The galaxy appeared to contain almost none of it. That discovery was shocking because dark matter is thought to be the invisible glue holding most galaxies together. Finding a galaxy without it showed that the universe still has ways of surprising us, and that even our strongest theories can be challenged by a quiet, faint world drifting in the dark. The moon holds a resource that could one day power entire civilizations. Its surface soil contains small amounts of helium-3, a rare form of helium carried there by the solar wind. On Earth, it is almost impossible to find, but on the moon, it rests just beneath the surface. If future miners could scoop up and process lunar soil, helium-3 could become a clean fuel for advanced fusion reactors. The search for cleaner energy may start with simple tools on a quiet, moonlit plain where new possibilities wait beneath the dust. In the far future, when stars fade and galaxies drift apart, the universe will grow quiet. Yet quantum physics says that even in this stillness, tiny fluctuations never fully stop. Given enough time, those random ripples could assemble something unexpected, like a single conscious mind forming out of scattered particles. This idea is known as a Boltzmann brain, and it challenges our sense of reality by asking whether a lone moment of awareness born from chaos could ever outnumber the minds created by entire civilizations. Some worlds travel through the galaxy completely alone. PSOJ 318.5-22 is a rogue planet drifting without a star to orbit. With no sunrise or sunset, its only light comes from its own fading heat, left over from formation. Its skies would be pitch black, and its atmosphere glowing faintly like warm embers in a vast cosmic night. Worlds like this reveal that not every planet needs a home system. Some simply wander through the darkness carrying their own quiet story. Some stars move so quickly through the galaxy that they reshape the space around them. As they plow through thin clouds of gas, their powerful stellar winds compress the material ahead of them into a curved, glowing wall, called a bow shock. It forms the same way a boat creates a wave as it cuts through water, but on a scale far larger than entire solar systems. These sweeping arcs reveal how even a single runaway star can sculpt the quiet darkness into dramatic and beautiful shapes.